Alright, this is Mr. Holly back for lesson 16, part 2. We're looking at example 2 using the distributive property. So let's review the distributive property. The distributive property is the idea that if I have A times the sum of B plus C, that's the same as A times B plus A times C. Now, what would also be true, though, is just the converse here. The idea that A times B plus A times C, if I have ABs and I have A times ACs, some number A, then I would also have A times B plus C. This is called factoring, but it is a use of the distributive property. It's application of the distributive property. Okay, so now we're going to multiply mixed numbers by using the distributive property. So I can think of 5 1/3 as 5 plus 1/3. And now I can do this multiplication. Negative 6 times 5 is negative 30. Plus negative 6 times 1/3 is, well, 6 over 3. That's going to be 6 divided by 3 is 2. It's negative, so negative 2. And my answer is negative 32. Same thing down here. I can do 9 times negative 3/2. So that's negative 3 plus negative 1/2. If I have negative 3/2, the entire quantity is negative. So it would be a negative 3 and a negative 1/2. Okay, 9 times negative 3, negative 27. Plus, now this one doesn't play nice. Like 9 and 2, 9 is not equally divisible by 2, so I'm not going to end up with a whole number. I'm not going to end up with an integer here. But if I do 9 divided by 2, that's just going to be, I'll just represent that as 9/2. Yeah, let's do that first, negative 9/2. Now I can probably just go ahead and write that as a mixed number. I think that's going to be the best way in this case. 2 goes into 9 4 times with 1 left over. So I get negative 4 and 1/2. Negative 27 plus 4 plus negative 1/2. And that's going to give me negative 31 and 1/2. All right. Now, let's look at the next example. And before we do, I want to remind you the distributive property can also go the other way. If I have A times B plus C, I can rewrite that as A times B plus A times C. Or excuse me, if I have, yes, I can rewrite it like this. Okay, let's go to the next page. Now, if I were to look at these numbers, going back to our definition, I would think of 16 as if it were A. I would think of negative 3/8 as if it were B. So I have A times B plus 16 is A again, and 1/4 is C. Can we see that? Can we see that we have one number times some number A times some number B. Now we have that same number A again times a third number C. Okay? So anytime I have this, I can rewrite it as A times B plus C. So I would rewrite this as 16 times negative 3/8. Because this is addition, it would be plus 1/4. Now I can work with these fractions independently before I do my multiplication. Keeps everything a little more simple. So here I'm going to have negative 3/8 plus 1/4. I would try to find a common denominator here so that I can add them together, which that would obviously be 8. So I would take 1/4, I would multiply by 2 over 2, and I would get 2/8. So now negative 3/8 plus an equivalent fraction here is 2/8. Negative 3/8 plus 2/8 is going to be negative 1/8. 16 times negative 1/8 would be negative 16 over 8. 16 divided by 8 is 2, so it's negative 2. That's supposed to be a shortcut. I think I can shorten it for you. And I'm going to show you, but it goes back to this idea of trying to create numerators and denominators that can cancel out. I apologize for the bell. Now, let's see if we can cancel out our numerators and denominators to create a more simple problem. Okay, so if I think about this as every number in this problem as a fraction, like this is 16 over 1, this is 16 over 1, well, I can look at this multiplication and we can cancel. If I had a 16 in the numerator and an 8 in the denominator, 16 over 8, I can divide each of those by 8, and this becomes a 2, and this becomes a 1. Here I can do the same thing. 16 in the numerator, 4 in the denominator. What could I divide both those numbers by? By 4. 16 divided by 4 is 4, and 4 divided by 4 is 1. So now I have 2 over 1 times negative 3 over 1. Well, that's 2 times negative 3, which is negative 6. And 4 times 1, which is 4. Negative 6 plus 4 is negative 2. This is a lot easier to me. But I do know some kids that struggle to see this canceling out between the numerator and denominator. Keep practicing. Okay, next. Using multiplicative inverse to rewrite division as multiplication. Remember that multiplicative inverse means that anytime I divide, it is the same as multiplying by the reciprocal. We don't use keep, change, flip or other, just common phrases. In 7th grade, we use academic vocabulary. So we need to know that division is the same as multiplying by a reciprocal. Okay? Here you see division twice. So I can rewrite that just like earlier we wrote all subtraction as addition. We just made the numbers the opposite. Well, now we're rewriting all division as multiplication, and I do that by using the reciprocal. So 1 times, instead of division, I'm going to make it multiplication, and I have to multiply by the reciprocal, 3/2. Times negative 8 times 3 times, well, this is division. I'm changing it to multiplication, so this has to become the reciprocal of 1/2, which is 2. So in this case, negative 2. Okay? And now I can just look for something that would easily cancel out. What number is easily going to multiply with 3/2 to eliminate this 2 in the denominator? Well, any even number would work, but you know what would work really nice? 2. 2 would work really nice because they cancel. And that becomes negative 1 times negative 8 times 3. Now, anytime we multiply by 1, this is just the identity property. Any number multiplied by itself is still equal to 1. So when we're multiplying by 1, we can really just get rid of those factors because the number is going to stay the same. We do need to realize that there is a negative here, so I'm just going to remove the 1s. 1 times 3 is 3. Negative 1 times negative 8, that's going to cause it to become positive. So 8 and then 3. And I can multiply these in any order. I think I'll do 3 times 3 is 9. 9 times 8 is 72. All right, let's come down here to the bottom. The last one is 4 2/3, or excuse me, 4.2 times negative 1/3 divided by 1/6. I need to change that to times 6 over 1. Hopefully you're seeing like, oh man, that just made it really easy. Times negative 10. All right, so now this looks complex because we've got decimals, we've got fractions, we've got all this stuff. But if we multiply the right numbers together, we get rid of the decimal. And if we multiply the right numbers together, we get rid of the fraction. I'm going to rearrange the order of these. 4.2, or 4 2/10, times negative 10, and negative 1/3 times 6 over 1. And if I multiply these two together, and I multiply these two together, we're going to get rid of our decimal and we're going to get rid of our fraction. 4 2/10 times negative 10, that's negative 42. Negative 1/3 times 6, 6 over 3 is 2, and it's a negative times a positive, so that's negative 2. And negative 2 times negative 42 is 84. So, as you can see, this could have been really hard. 4 2/10 times 1/3, that's a mess. I don't want anything to do with that. But if we multiply the right numbers together, if we use products and properties that allow us to commute the numbers, associate the numbers, distribute the numbers, and in this case we are changing all division to multiplication by multiplying by the inverse, you really can create a lot of friendly ways to multiply the numbers that eliminate a lot of the struggle that you might have. So work smarter, not harder, and you're in control of these numbers. So as you go through these problems, see if you can make it as easy on yourself as possible. All right, thanks.